Hello all, welcome to Hadoop online training demo. I am going to give you demo on big data and Hadoop. What is big data and Hadoop? So big data is the amount of the data that is beyond the storage and the processing capabilities of a single physical machine. And big data has the extra large volumes, comes from the variety of the sources, variety of formats and come to us with a great velocity. That's normally referred as the big data. If you will see the real-time example, till couple of decades back, we were using floppy disk where we have the storage in the MB like 25 MB kind of, and then we started using CD DVD drives where we had storage like 40 GB, and then half a decade back we started using hard drives with the storage of 500 GB. But now if you'll see that we are having 1 TB storage in our laptop and we are using external hard disk which has a storage of 1 TB. So data is growing in our personal life. Similarly, IDC has estimated that data is doubling in the size every 2 years for any company. And the shapes of the data can be in any format, like it can be mobile data, social media, messages, email, audio, sensors, clickstream. And the size of the data for some big company like Facebook, Google, eBay, you can see Facebook is generating 300 petabytes of the data every month. Google is generating 400 petabytes of the data every month. Similarly, eBay 250 petabytes data generating every month. And IDC estimated that by 2020, the size of the data can be 44 zettabytes. So, if we are going to see the characteristics of the big data, so there are three characteristics: volume, variety, and velocity. So volume, as we have seen just now, that it's in the size for any company, like if it can be like in the petabytes, it can be in the zettabytes, it can be in the terabytes. So data is growing for any company and in personal life as well. So that comes in the volume where the size of the data is growing. And second is a variety where we have three kinds of the big data. So first will be the structured data, second semi-structured data, and third unstructured data. So structured data like in the Oracle database where we have a schema, where we have a table, where we are storing the data in proper format. So suppose I have employee table, so I am storing the first name, last name, their gender, their marital status, blah blah, so many things in a one table. Okay, so that comes under the structured data. What is semi-structured data? So like XML files where we don't have a proper format and we are storing the data under the XML file, that comes under the semi-structured data. Similarly, your mail like emails, that also comes under the semi-structured data. How? If you have if you are having footers and header in the mail, like suppose your mail ID and whom you are sending, and then in the uh, we are writing the contents, and then in footer like we are having some our signatures, so that comes under the same structured data. Okay, where some things in the proper format but some parts is not in the proper format. Okay, third is the unstructured data. So like uh, if you have a Twitter's account, so you are tweeting anything, so that data is getting stored as a unstructured way. Similarly, like audios, videos which we are uploading in the Facebook, that also comes under the unstructured way. So these are the variety of the big data. And third is the velocity, like how frequently your data is changing. Okay, so in share market you can see that data is changing in a seconds. Okay, similarly, like for any ATS signal in the airport, like by flight they are sending the ATS signal, so it's getting stored in a second, in a minute, every seconds they are sending the data. So that you can see that how frequently data is coming. So that's a velocity. So if you will see this graph, you can see that growth of the structured and unstructured data since 1980 to till 2020. You can see this gray color data growth is not much if you will compare with the unstructured data. Okay. So growth of the unstructured data is more than structured data. So unstructured data will account for more than 80% of the data collected by organization. Okay. So how come the growth of the unstructured data is more than structured data? So if you will notice that everything become e-commerce, like for buying a vegetables or like for buying any products, like electronics products or anything. Nowadays, everyone placing the order online and getting their products. They no need to go for any shops, any retail electronic shop or like any like grocery market. They are sitting at home. They can place the order and they can get their products. Okay. So those online data is getting stored. Okay, so if you're completing your transaction, so getting stored in a structured way. If you're not completing your transaction, so like there are many people who are just exploring the products and they're not making any transaction. Or like Facebook audio, where Facebook where we are uploading that audio video, Twitter where we are tweeting, LinkedIn where we are having the connection, we are having so much data there. So those data is the unstructured data. Okay, and it's more than that structured data which we are having in the Oracle or in the Teradata. Okay. So companies are thinking that if we are processing this structured data, so they are getting some benefits, business growth. Okay, so if they are thinking that if they process to unstructured data also, definitely there will be some business growth. And the challenges are how to store this big data, okay, which is more than 80% of the data collected by the organization. Okay, and how to store and then how to process it quickly. So the current traditional system like Oracle data warehousing or like SAN storage area network where we can store the data and then process it, it's taking a long time, and again there is some limitation. So limitation till terabytes we can store the data, but if you want to go beyond of that, it would be very difficult. If you want to store that petabytes data, so 1 petabyte is equal to 1000 terabytes. So it's very difficult to store that huge amount of the data in the single machine. So you can see this. This is a storage area network, and these are the application server. So this application server are connected with the storage area network. In the storage area network, suppose if we are storing that 50 TB data, and with the help of this application server, if we are processing 1 TB data per application server, so to read the data from the storage area network, then process it and then write it back to storage area network, it's a very cumbersome job, and then again it's taking long time. So the problems with the typical distributed system are huge dependency on the network, because it's reading and writing back the data using the network. Okay, so huge dependency on network and huge bandwidth demands. Scaling up and down is not a smooth process. Partial failures are difficult to handle. A lot of processing power is spent on transporting data, and data synchronization is required during exchange. Okay, so scale up and down, like if you have a laptop with i5 processor, so there would be limitation. If you're working in the vertical manner, like where we have, suppose if you want to increase the RAM size from 4 GB to 8 GB, and then from 8 GB to 16 GB, you can do that. But if you want to increase more than 16 GB where you have i5 processor, it would be difficult. So when you are working in the vertical growth manner, so it would be very difficult because it has some limitation. So scale up and down is not a smooth process. Okay. Then partial failures are difficult to handle. So you can see that there can be partial failures, like your one application server can be down for some reason, like network crashes, network issues, or disk crashes, or anything. Then there can be possibilities you can lose the data. And again, lot of processing power and data synchronization is required during exchange. So these are the problems with the typical distributed system. And if you will see that Oracle or data warehousing tool, so again, if you want to process even 1 TB data with this data warehousing tool and the Oracle database, it will take long time. So it's not easy. And again, to store, even if you want to store like more than 20 TB data or 30 TB data in this tool, it would be very difficult. And then again, processing will be next to impossible job with this machine. So why and what Hadoop? So Hadoop is nothing but typical distributed system which solve that 5 problems, and it's a tool to process big data. It's an open source framework provided by Apache. It works across the cluster of computer using a single programming model, MapReduce. So why do we need Hadoop? So data is growing faster, need to process multi-petabytes of the data. The performance of traditional application is decreasing, and the number of machines in a cluster is not constant, and failure is expected rather than exceptional. So to overcome this issue, we need Hadoop, because Hadoop is a framework where we can store the multi petabytes of the data, but you are not going to store that data, that huge amount of the data in a single machine. You are going to store that in a distributed manners. So you can see here, as I told you before as well, till terabytes you can handle with the existing system. But if you're going beyond of terabytes, like in the petabytes or zettabytes, it cannot be handled with the existing system. So history of Hadoop, like Google started working on it and they have launched GFS and MapReduce. So they published a paper in 2004 announcing the world of brand new technology, and this technology was well proven in Google by 2004 itself, but it was on white paper. Then Yahoo started working on it, and in 2007, and then like they have developed HDFS and MapReduce. Then now Hadoop is core part in the Facebook, Yahoo, LinkedIn, Twitter, and many other companies. So Hadoop consists of the two core components. One is the HDFS, Hadoop Distributed File System, and second is the MapReduce. Okay. But apart from that, there are many other projects based around core Hadoop, often referred to as a Hadoop ecosystem, like Pig, Hive, HBase, Plume, Uzi, Scoop, etc. So a set of machines running HDFS and MapReduce is known as a Hadoop cluster. So we are having multiple machines and where we are running HDFS and MapReduce. Okay. So individual machines are known as nodes, and cluster can have as few as one node, as many as several thousands. Okay, so more nodes equal to better performance. How? I am going to show you. So you can just assume that it's a hill. On the hill there is a diamond, sorry, gold. Okay, and I need to get this gold from this hill. I am putting one crane where I am applying one algorithm. Okay, and this hill in an unstructured way. Like there could be trees, there could be mud, there could be animals, there could be stone, there can be anything. Okay, so with the help of this crane and algorithm, in algorithm I have mentioned, suppose if something is glittering and something is in gold color, get me that thing. So this crane will start exploring this hill, like from here, then here, and then here. Okay, so it will take almost 24, suppose 4 months, or like more than even 4 months. So what we can do, if we add more crane and apply the same algorithm which we have applied on the first crane, okay, and we divide the area like this. So at this area, in this area, one crane will work, in this area other crane will work, in this area other crane will work, and in this area other crane will work. Okay, so with the help of this 4 crane and the same algorithm, we are getting this work done in a 1 month. Okay, so it's called distributed parallel processing, and Hadoop is working in the scale out mechanism. What does it mean? You are having the multiple machines, and if you want to improve the performance, you can again add multiple machines. Okay, in technical terms we say nodes, data nodes. Okay, so we are having multiple nodes, and in one cluster there can be multiple nodes, as I have told you. So a cluster can have as few as one node, as many as several thousands. Okay, so we can have multiple nodes, and then we are dividing the data. So you can see that we are dividing the area in hill. So it's assume that this is the data which we are dividing. Okay, and we are storing that data in the data nodes. So data HDFS is a place where you are keeping your data. So it's like a hard disk where you can store your data. So in Hadoop, HDFS is a location where you can store the data in HDFS format. So, and your data is getting stored in the distributed manner. So suppose if you have 500 MB data and 4 nodes are there, or suppose 5 nodes are there, and then I have 500 MB data. Okay, so 100 MB data will be on data node 1, 100 on data node 2, and so on. So 500 MB data will be distributed among the 5 nodes. Now if something happens to one node, if this node is getting down for some reason, so I am going to lose this 100 MB data. So for that purpose, Hadoop has given the replication factor where we can have copies of the data. Okay, so this 100 MB data again will get copied on the other node. Okay, so for that you can take a decision like replication factor, what you want to give, whether it's a 1 or 2 or 3 or even more than 3. So by default, Hadoop has given the replication factor is equal to 3. So you are going to have 3 copies of the data. So this 100 MB data will be present on other two location, on other two data nodes in the same size 100 MB, 100 MB. So suppose if something happens to one node, you are not going to lose any data from the other nodes. So that's the best part of the Hadoop. And if after some time, if it recovers automatically, then Hadoop can assign that work to this, can assign the new work to this data node. Okay. So HDFS is a Hadoop distributed file system, is responsible for storing the data on the cluster. And as I told that your data files are split into the blocks and distributed across multiple nodes in the cluster. So your data is distributing in the blocks, and by default size has been given in the Hadoop 64 MB, and there are two versions of Hadoop, Hadoop 1.0 and Hadoop 2.0. So in Hadoop 1.0 by default block size is 64 MB, and Hadoop 2.0 the by default block size is 128 MB. And as I told that is block is replicated multiple times, so it's all depend on your application factor whether you are giving 2 or 3. So with the help of with that configuration, your data is getting copied on other data nodes, so client is not going to lose any data. This is the HDFS architecture. You can see data node 1 2 3 4 5, and Hadoop is working in the master slave architecture. So master will be the name node in technical terms of Hadoop, and slaves are data node. Okay, so your master is having all the controls, and when it will get the data, it will distribute among the data nodes. And you can see this orange color data, so it's a block like orange, green, pink, blue, green, all those. And then you can see that orange color data has been replicated 2 times more on the other data node. Okay, so in any case you are not going to lose any data, even though if your data node 1 will stop working. So data node is sending the hard bits to the name node, and name node will, after getting that heartbeat, like it's knowing that your data node is alive. If data node is not sending the heartbeat, then name node will assume that data node is not alive. Okay. And MapReduce plays a key role in Hadoop framework. Okay, it's a programming model where you are writing the code in core Java or Python, and like you are writing applications that rapidly process large amount of the data. So your computation and storage is having on the same machine. So like in in data node you are storing the data, and even MapReduce you are triggering there only. So under MapReduce there is a two method, mapper and reducer. So it's a function that process input data to generate intermediate output data. Reducer merges all intermediate data from the all mappers and generate final output data. Okay, so you are processing large scale data in parallel. MapReduce provides automatic parallelization and distribution. Fault tolerance, as I told that if one node fails, the master will detect that failure and reassign the work to a different node on the system. Restarting a task does not require communication with nodes working on other portion of the data. If a failed node restarts, it's automatically added back to the system and assigned new task. So as I told that if your failed node recover automatically after some time, then it can be added automatically and assigned a new task. If a node appears to be running slowly, the master can redundantly execute another instance of the same task. Okay, so if you feel like, if the master feels like that one data node is running slowly, then it will execute same task on the other data node. So two phases: map reduce, map and reduce. So everything will be in the key value pair in the map reduce code, which we'll see in the map reduce code. Okay, and this is the Hadoop ecosystem. So in our class, we are going to cover MapReduce, HDFS, HBase, Zookeeper, Uzi, Scoop, Flume, Huey, Hive, Pig, and Mahout. And Hadoop is being used across multiple industries. So where you feel like, where you have large amount of the data, so you can use Hadoop. Okay, and companies are starting using Hadoop because it's working on the commodity hardware. It's open source. Okay, so there is no licensing cost, and again, the companies are having the challenges to store the big data and then process it. So they are investing in Hadoop because it can store any amount of the data and can process it quickly as well. So if you will compare with any other product, Hadoop is best in current market. Okay, so what is Flume? So Flume, if you want to get the data from the different server which are located in different countries or different cities, so you can collect that data from the log generating sources like websites, syslogs, std. Scoop, if you want to get the data from the relational database management system uh, to the HDFS, you can use Scoop and then you can get the data. Similarly, Hive, Pig, it's a structured query language like interface to Hadoop. To query any data in Hadoop, you can use the Hive. So if you don't have much knowledge on uh, core Java, then you can use the Hive, but Hive mainly used for the structured data. Similarly, if you don't have much knowledge on core Java, then you can use a Pig. With the help of Pig, you can process structured as well as semi-structured data, and unstructured data you can process it partially. Why? Because if it is completely mashed up your unstructured data, then it would be very difficult to process it with the Pig. And HBase is a schema-less database. It's called NoSQL database also. Okay, where we are storing the data in the key value pair. So we are going to cover each and everything in our class, and it's completely hands-on. And we are going from basic level to the advanced level in Hadoop. So case study. So some national bank. Okay, with the help of Hadoop, you can identify credit risk, fraud, proactively manage capital. Okay, and before Hadoop, to process even 1 TB data, it was taking long time. It was taking 20 more than 24 hours. It's very hectic. Then writing back, reading the data. So it's very difficult with the traditional system. And the storage wise, if you will see the cost before Hadoop, Yahoo was spending 1 million for 10 TB storage, but with the Hadoop, you can save the cost like this: 1 million for the 1000 terabytes of the storage. Other large company before Hadoop, 5 million to store data in Oracle, but with Hadoop, 240K to store the data in HDFS. So that's all about Hadoop and big data. So we are going to cover each and everything of Hadoop ecosystem, as I told, and you are going to get advanced knowledge on Hadoop and big data. Thank you. Okay, one more thing, like the prerequisite for this: core Java, structured query language, and Unix. So Unix, while executing the code, you will get those commands. You will get used to those commands. But core Java and structured query language is required. for Hadoop and big data. Thank you.